Okay folks, here's lesson 3. This is going to be on activity and half-life. So by the end of this, you should be able to state that the activity is measured in something called becquerels, which has the symbol BQ. And you should be able to know that the activity of a radioactive sample source decreases with time. So activity first. Radioactivity is measured in something called becquerels, and it's got the symbol BQ, and it's the number of nuclear decays that happen every second. So if 50 nuclei break up every second, so 50 divided by 1, then the activity is 50 becquerels. And what we do is we use this equation here, A equals N over T. So A is the activity, N is the number of nuclei to decay, and the time is T is the time taken for this to happen, and again that's always in seconds. Activity is not constant, it decreases over time, so if you have A equals N over T, as time increases, as that number gets bigger, the activity decreases, and you could type any numbers in just to prove that. Okay, here's an example question. A material has 1800 decays happen in 3 minutes. So do your little data bank. You've got your N, which is 1800 decays. You've got your time, which is 3 minutes. It needs to be in seconds. So that's 180 seconds. And you're trying to calculate the activity. Activity equals number of decays divided by time. 1800 divided by 180. 10 becquerels. 3 marks. You get 1 mark for the equation, 1 mark for plugging in the right numbers, which includes converting your minutes into seconds, and then you get your final mark for your answer and correct unit. Another question. A material has an activity of 500 becquerel, so it already has your activity. How many decays will happen in 10 seconds? So for those of you that like these, we'll try to calculate N. So N equals A times T. The activity is already in becquerels for us. If it was in kilobecquerels, say that was kilobecquerels, then you know you would need to times by 1,000. Megabecquerels, you would need to times by 1,000,000. You should all know that from previous topics anyway. 500 times 10, 5,000 decays will happen. Right, half-life. Here's an example of a half-life graph that you might see here. I'll come back to that in a minute. You will need to know the definition of half-life. Half-life is the time taken for the activity of a source to fall to half its original value. So how long will that take? Let's go back to that previous graph. So can you see this is all starting at 80 here? So if that's going to decrease to half its counts, it's going to go from 80 all the way down to 40. And how long does that take? Go along to here, and it takes 2 days. So the half-life of that source would be 2 days. Let's just double check. It goes from 40, half 40, down to 20, which is here, which is now 4 days. So that's another 2 days. So that's went through another half-life. Let's double check the next one. 20 down to 10, which is here. 6 days in total. So that's another 2 days to half. And then 10 down to 5 is roughly here. So yeah, another 2 days. So the half-life of this source is 2 days. because every 2 days it counts half. And here's another example. If a source starts at 100, the time taken for it to decrease to 50. So 100 half down to 50 is its half-life. Right, I just want to give you an example. We're going to talk about uranium in a minute, but I just want to talk about paracetamol. Paracetamol might be a drug that enters the body and then exits the body, but it has a half-life as well. So let's say you take a paracetamol, you've got a sore head, you take a paracetamol tablet, that's usually got around 500 milligrams in it. So you take one of those, say at 8 AM. The half-life of paracetamol is roughly 4 hours. So after 4 hours, you're going to have 250 milligrams of that still in your body. So at midday. After another 4 hours, so at 4 PM, you're not going to have zero, it constantly halves. So now you're going to have 125 milligrams at 4 PM. Another 4 hours, at 8 PM, you're going to have 62.5 milligrams. So you see these people that take numerous tablets per day, you may take another one at 4 PM, but you've already actually got 125 milligrams in your body. 8 PM you've got 62.5, and then another 4 hours, say at midnight, 12 AM, you've got half of 62.5, which is 31.25 milligrams. You've still got that amount in your body. So from this you should be able to see how half-life works. Now uranium, you all know uranium, it's got the symbol U, it's in the periodic table, it's a radioactive element. Now an isotope of uranium has a half-life of 704 million years. So that accounts for quite a lot of the background radiation in here. So let's just say uranium was made on day 1. So it has 100% of its source here. After 174 million years, that will go down to 50% activity. And then after another 704 million years, that will go down to 25% of its activity, or that would be a half, that would be a quarter. After another 704 million years, it would go down to 12.5% of its original source, or an eighth. And then 704 million years, 6.25% of it still left, or a 16th as a fraction. You see uranium is going to be around for a very, very long time, long after we're born anyway. 704 million years half-life. Right, let's do this final question and then I'll give you a list of what you need to be doing for this week. So the activity of a source falls from 80 megabecquerels to 5 megabecquerels in 8 days. What is its half-life? So the best way to work this out is constantly half your number until you get to the second number. So 80 is going to half to 40. 40 is going to half to 20. 20 is going to half to 10. And then 10 is going to half down to 5. So instead of going that way, it goes around this way anti-clockwise. So can you see it's went through 1, 2, 3, 4 half-lives. It's 4 half-lives. So that total time is 8 days. So if 4 half-lives is 8 days, then each one of these must be 2 days. So that's 2, 2, 2, 2 days, because 2 plus 2 plus 2 plus 2 equals 8 days, and that's what it is. So the half-life of the source in this question is 8 days. Okay. Right, I hope you understood that. If you have any questions, you can let myself or Miss Murray know. If you now go to your OneNote, you could see that all the learning intention success criteria for this topic are here. You've got your resources, the PowerPoint and the video that you're watching at the top. If you prefer reading about activity and half-life, I've also inserted them there. But if you've understood this video, you don't really need to read them, but you can give them a quick read anyway. Now I want you to move on to the tutorial questions. There's tutorial questions on activity. There's tutorial questions on half-life. And then they're not there right now, but there will be past paper questions on activity and half-life for you to do. Okay, best of luck.